Hi guys, this is a quick video on Unit 3, Activity 3 stuff. So I've gotten a few emails that this unit is giving people some trouble, or this activity from analytic geometry. So let's just go through what's in the content. So I'm just winging this. Okay, so it looks like the first thing they're talking about is slope-intercept form of a linear relation. So that looks like y equals mx plus b. And they call it slope-intercept form because you can easily identify the slope and the y-intercept of the line. So the slope is m. So it's the coefficient in front of x. So that's our slope, also known as rate of change. And then b is your y-intercept. So that's where the line crosses the y-axis. So just to give you a little visual, let's just say we had this line. Say our line looks like this. So just recapping, the y-intercept is this value right here, whatever that is. I just made up this line. Sorry about these messages. Oh goodness. So say that's like 1, so that could be our b value, and then our slope is going to be just whatever our rise over our run is to get our slope, so like the steepness of our line. So that's what slope-intercept form is. It's when we know we can easily identify the slope and y-intercept. Okay, so the next thing in this unit is just kind of looking at slopes and what happens when you have a positive slope, a negative slope. What about a vertical line? So yeah, you're just kind of exploring slope a little more. So I kind of already did a video on this, but just a quick recap. So we kind of already said like slope is the steepness of our line. So if we have a bigger value for slope, our line's going to be steeper. So just for example, if this is our graph, and let's just say we had a slope of 2. Maybe that looks like this. And then, so let's just say, hey, we just made up a line with a slope of 2. I just randomly made that. There's like no grid lines here, so it could be anything. And then how does that compare to a slope of 4? So maybe a slope of 4 looks like this. So we know it's just like a bit steeper. And what does a negative slope look like? So also just kind of experimenting with, well, if a positive slope of 2 looks like that, then a negative slope of 2 would look like this. So slopes that are negative kind of go down. If you read them from left to right, they're going down to the right. And then we also talked about in this unit vertical lines, which are kind of crazy, but a vertical line like this, straight up and down, turns out their slope is undefined. And if you think about it, that kind of makes sense because you know how slope, we calculate slope by saying rise divided by run. And if our run, like if you have a vertical line and you're trying to kind of make a triangle to show like what's your rise over your run, or say you pick 2 points on your graph, we can't make a triangle. It's just going straight up from one point to the next. So we can have a rise. Our rise could be whatever. Say it's like 2. I don't know. But when you have to calculate the run, well, we're not going over any amount. We're just going straight up. So our run would just be 0. So if we had to find the slope, we'd have 2 divided by 0. And since we can't divide by 0, we would just say our slope is undefined for a vertical line. And then we said for a horizontal line, looks like this. So similar situation. If you picked 2 points on your horizontal line, it looks like in this case you'd have a run. So you could say like, oh, between these 2 points, it's going over 2. But we're not going up at all. So the rise of our line would be 0. So in this case, if we're doing slope, rise divided by run, 0 divided by 2 would just be 0. So a horizontal line has a slope of 0. So that's just kind of like our slope summary. So we learned that in activity 3, we learned that the bigger the number, the steeper the line. We learned negative slopes slope the opposite way, so down to the right. We learned vertical lines have an undefined slope, and horizontal lines, totally flat lines, have a slope of 0. That's kind of what we learned about slope. And then Y-intercept, we just learned, like, it's just wherever the Y-intercept is just wherever your line crosses the Y-axis, and the Y-axis is this vertical axis right here. So the Y-intercept is just wherever the line crosses that point. And then the other thing we did, in this unit was sorry, I can't scroll down. There we go, kind of. The other thing we learned was just that if an equation's in slope-intercept form, like y equals 3x plus 7, then we learned it's really easy to identify the slope in the y-intercept, because the slope is just the coefficient in front of x. So this line has a slope of 3. And the y-intercept is just this constant on its own. So the y-intercept is 7 in this case. And then like the oddball cases are just things that don't look just exactly like that. So if you have y equals negative 2x, well, here we can see, since this guy is the coefficient in front of the x, we know that the slope would be negative 2. But we don't know what the y-intercept is because it's not there. So we could assume, well, since it's not there, it's like you're adding 0, which you don't need to write. So our y-intercept must be 0. And then what would a horizontal lines equation look like, or a vertical lines equation? So if you had a horizontal line, you know that your slope is going to be 0. So if you think about that, if you had y equals 0x plus b, as soon as you put that 0x in, this term is now gone, because 0 times x is just going to be 0 no matter what. So if we wanted to graph a horizontal line, say we graphed it here and its y-intercept is 2, then our horizontal line would look like y equals 2. So there would be no x term because our slope is 0, so that would be gone. And then the other weird one would be a vertical line. So if you had a vertical line, let's say we had a vertical line that goes through 3 on the x-axis. Mine doesn't quite go through there because I can't draw a straight line. There we go. Okay, so say we had a vertical line, and now we know our slope is undefined. So that's crazy. And then we also know that I can see right from my graph here, there's no y-intercept. Like there's no way this line's ever getting over to the y-axis. So I'm also not going to have a y-intercept. And it's not that it's 0, because that would be here. It's that it's actually not there. So vertical lines are written as, like, if you check out the way a horizontal line's written, y equals 2. Like y is always 2. That's the y value forever. No matter what your x value, y is 2. So vertical lines are similar. The x value right here is 3. So x equals 3. So as you can see, like the x value is always going to be 3, right? If y was 7, x would be 3. If y was negative 5, x would still be 3. If y was a billion, x would be 3. So how we write vertical lines would be like this. X is equal to 3. Okay, so that kind of sums up the slope and the y-intercept and the sloped-intercept form. So then the only other part of activity 3 was kind of like your real life-ish things, I think. I believe. So that was just kind of like taking what we learned and applying it to real life. So just kind of making slope more realistic and y-intercept more realistic. So when we talk about like linear relationships in the real world, the slope ends up being kind of like the rate that's, it could be like the rate that someone's charging to shovel their driveway, or the cost of every bowling game if you're out bowling or something. So the slope is like your rate of change, like your thing that's constantly changing. And And your Y-intercept, it's like your initial value, your starting cost maybe. Depends on what this scenario is. So in the website, it was a bowling example, and also somebody working as a dog walker. So the dog walker question, they charge $12 per hour to walk dogs. So if they're not walking dogs, they're not making any money. So basically there was no initial value. So if this girl, Anna, doesn't work at all to walk any dogs, she's making no money. So her Y-intercept's 0. That's like her initial value. And then her rate of change is 12 because every hour the graph is going to go up by 12 because that's how much she charges to walk a dog. So after the first hour, she's going to make $12. Then after the second hour, she's going to make $24. And it's just going to keep going up that way forever and ever. So that's the dog walker question. Whereas the bowling question, there was actually an initial cost in the bowling question because, okay, each bowling game is $6 a game. So like your graph's going up by $6 every time because every time you play a game, you pay $6. But there was an initial cost of the shoes. So it turns out our graph actually started at 3 if you're following along with the content. So the shoe cost is like a fixed kind of cost, so you're gonna have to pay that $3 no matter what, and then you're gonna have to pay an additional $6 every time you play a game. So if you play one game, you're gonna have to pay $9, right? 4, 5, 6, 7, 8, 9. Because $3 for the shoes, $6 for the game, that puts you at $9 for one game of bowling. If you play 2 games of bowling, now you got $6 plus $6, that's 12, plus your shoe rental, so 15. It's like not gonna fit on my graph, but you know what I mean? It's gonna go up like that. So in the bowling question, you have an initial value, which is your shoe cost. Whereas the dog walker, she's just charging a straight hourly fee, which is your rate. So that for the second page of the content in activity 3, we were just kind of putting a real life aspect to slope and Y-intercept. But basically, yeah, you're just in this activity, you're just trying to understand like slope, Y-intercept, and what it looks like in a slope-intercept equation. And just as an additional piece of information, if you want to know how to graph a line from slope-intercept form, if that's giving you any trouble, let's just see if I can just change my paper to graph paper, which I can. Sweet deal. So if you have an equation like y equals 2x minus 4, and you wanted to graph that line, so let's make a grid here. Or sorry, let's make a set of x and y axes. Okay, so there's my x-axis and my y-axis. So what I would recommend doing is starting with your y-intercept and plotting that first. So here the -4 is your y-intercept. So let's figure out where -4 is on our y-axis. So it'd be like 1, 2, 3, 4. It'd be like right here, -4. And then we have a slope of 2. So a slope of 2, if you wanted to write that as a fraction, you could write it as 2 over 1. And that basically just gives you your rise and your run. I also know that's a positive slope, so I know it's going to be going up to the right. So I know I want my slope to look like that, not down to the right, because it's not negative. So if I'm doing a rise of 2 and a run of 1, I could just go up 2 over 1, up 2 over 1, up 2 over 1. I could just keep doing that forever and ever. And you could totally go down 2 over 1 as long as you're keeping your line in this direction, up to the right. And then I could just connect those with a line, and there you go. That's how you could graph a line from slope-intercept form.